Hi, I'm Joe James. This is our fifth and final video in the series on linear equations. In this video, we're going to focus on how to solve systems of linear equations, or find the point of intersection between two lines that'll solve both equations. We're going to learn three different methods for doing that. First, we're going to learn the graphing method, then we'll use substitution, then we'll use elimination. Three different methods. I'll walk you through multiple examples for each one of those methods so you can see how they work. Now, the first method we'll look at for solving systems of linear equations is graphing. And the process here is we're going to graph both lines by plotting 2 points and then drawing a line through those points. And then we're going to find the intersection of those two lines, and that will be the solution to the system of equations. So let's take a look at a problem. Here are two lines. We're going to graph both lines and then find the intersection. So let's see. Let's find 2 points. The y-intercept is 1 point, right? Which is positive 2. So 0, 2 is 1 point. And we'll put in 2 for x and find another one. So 2, let's see, y equals negative, I put in 2 for x, and then we're going to add 2 to that, and we get 0. So that's 2 points on that line. Let's go ahead and graph it. 0, 2. 1, 2. Here is a point. And 2, 0. 2, 0 right here. So we got 2 points on that line. Now let's go ahead and find 2 points on the other line. Okay, so 5 is the y-intercept. So 0, 5 is 1 point on the second line. And we'll find a second one that has 2 for x, and we'll figure out what y is. So y equals 1/2 times 2 plus 5. So let's see, 1/2 of 2 is 1, plus 5 is 6. So 0, 5, and 2, 6. 1, 2, 6 right there. So those are our two lines. I've actually already drawn the line. So let's see. You can see the 2 points we plotted fall right on both lines. And then we can see here this green is a point of intersection between two lines. That is our solution to the system of equations. And what is that point? That's negative 1, 2 for x, and then 1, 2, 3, 4. So negative 2, 4 is our solution to the system of equations. Let's try another problem. Here we're going to find the intersection to these two lines. So let's start by finding points on both lines. This one has a y-intercept of negative 3, so 0, negative 3 is a point. And let's find another one. We'll just put in 2 for x. Y equals 2 times 2 minus 3, which is 4 minus 3, which is 1. So 2, 1. Now let's find 2 points on this line. Let's see, negative 5 is the y-intercept, so 0, negative 5. And let's find another one. We'll use 2 for x again. And let's see, y equals 1/2 times 2 minus 5. 1/2 of 2 again is 1. Minus 5 is negative 4. So those are our 2 points. Let's see, we have 2 points on each line. Go ahead and plot those, and then we'll draw the lines. So 0, negative 3. 1, 2, 3 right here. That's the first point. 2, 1. 1 is right there. Okay, and then we'll connect those. It's about as straight as I can make it. And let's see, 0, negative 5. 0, 1, 2, 3, 4, 5 is here. And 2, negative 4. 2, 3, 4 is right here. So that is our second line, which is going to look like, that. So roughly, our point of intersection is right here, right? So let's see, negative 1, 2, negative 1, 2, 3, 4, 5, 6, 7. Negative 2, comma, negative 7 almost. Negative 2, comma, negative 7 is our solution to the system of equations, because that point lies on both lines, or something pretty close to that. Our lines aren't perfectly straight, so we're probably off a little. But that is how the graphing method works. Let's look at a second method, substitution. In substitution, we're going to first solve for one variable algebraically, and then we're going to substitute that into the other equation to solve for the other variable. So we've got two variables, x and y, right? We need to solve for one of those two, and then substitute what we find into the other equation. So let's take a look at some sample problems. Here we're going to use the substitution method to solve this system of linear equations. So we have two equations that happen to be in the y equals, the slope-intercept form. And that makes it really easy because guess what? We can simply substitute this for y into the other equation. In other words, all we have to do when we have two equations in the slope-intercept form is set these two x sides of the equation equal to each other, right? If y is equal to this, and we're looking for the intersection, we can just put this in this equation for y. So, in other words, 3x plus 7 equals 5x minus 5. And then we solve for x. So let's see, we'll start by subtracting a 3x on this side, subtracting a 3x on this side. We do that, these cancel each other out, and we get just a 7 on the left equals 2x minus 5. Now we're going to add 5 to both sides to get rid of that negative 5. So plus 5, plus 5. These cancel each other out, and what we get is 2x equals 12, right? 12 equals 2x. And our last step is just to divide by 2 to get rid of that coefficient of x. So we'll divide both sides by 2. 12 over 2 is 6, so these cancel out. We get x equals 6. So now we've found, well, almost the solution to the system of equations. We know what x is anyway. Now we can plug that x into either one of these and find out what y is. So this one takes the least amount of work, I think. Y equals 3 times 6 plus 7, which is 18 plus 7, that's 25. So y equals 25. So what is our point of intersection between these two lines, or the solution to the system of equations? We can say x equals 6 and y equals 25. So again, our process was just to set the two equations equal to each other because we already have them in a slope-intercept format. So we substituted for y. And then we solved for x, and we got x equals 6. After we got x, we had to still figure out what y was. So we plugged x back into one of the two equations and calculated y. So that is our solution right there to the system. That's where the two lines are going to intersect. Now this one was easy for using the substitution method because we have these in the slope-intercept form, but you'll see in the next example we don't have them in the slope-intercept form. Instead they're in the standard form, so it makes it a little more complicated, but let's take a look at some of those. So here's a problem where we have them in standard form. Now what we're going to do again is solve for one variable and then substitute it into the other variable. So the easiest variable to solve here is the one that has no coefficient, or a coefficient of 1, which is this x, right? So we'll solve for this x. And to do that, we just need to isolate the x on one side of the equation. We'll do that by just adding 2y to both sides. Plus 2y over here. And we get x equals 2y plus 6. Now we can take this, 2y plus 6, and plug it into x here. right? And then we'll just have an equation with all y's in it. So we'll be able to solve for y. So let's do that. We'll rewrite this equation using this value in place of x. So 3 times, again, we're going to write 2y plus 6, where that x is. 2y plus 6, this is the substitution step, plus 5y equals 10. Now let's see, we'll multiply this out. That's 6y. This is just the distributive property. We have to multiply the 3 times the 2y and the 3 times 6. So we multiply the 3 times the 6, we get 18 plus 5y equals 10. Okay, let's combine like terms. Let's see, we have a 6y and a 5y. We can combine those two to just make 11y. And then we have a plus 18 equals 10. Now we need to get rid of the 18 because we're going to solve for y, right? We need to get rid of 18, so we're going to subtract 18 on both sides. Cancel out. Minus 18 here. And we get 11y. That is 10 minus 18, that's negative 8. And then when we divide both sides by 11, we get y equals negative 8 over 11. So now we know what y is. We can plug y back into any of these equations and solve for x. So actually, let's use this one. This is already in an x equals format, so this is perfect. X equals 2 times negative 8 over 11 plus 6. Okay, and then when we multiply that out, we get negative 16 over 11 plus 6. So that is 50 over 11, I believe. So our solution then is x equals 50 over 11 and y equals negative 8 over 11. And that is the point of intersection of these two lines. So again, what we did was we solved for x. We used one equation to solve for one variable, where here we just solved for x. We took that and substituted into the other equation in place of the x there, which is what we did here. And then we solved for y. We figured out that y is equal to negative 8/11ths, and then we took that y value back over here into one of these equations and we solved for x again. Let's try another one. Now we're going to solve this problem using substitution. So we want to solve for, let's see, one variable. It doesn't matter which one, and then substitute into the other equation. It's probably going to be easiest to use this x here again. However, we have a negative coefficient, so what we'll do is add x to both sides, and then we'll subtract away that 8. So plus x, and then we'll add an x to this side. And then when we rewrite that, well, these cancel out. We get 6y equals x plus 8. And then we need to get rid of that 8, so we'll do minus 8 on both sides. Rewrite that, we're going to get 6y minus 8 equals x. So now we can take this 6y minus 8 and substitute it into this equation where the x is. And what we do is get rid of one variable in the second equation. We get rid of the x's. So all we have is a y's for variables in this equation, so we can solve for y. So let's rewrite this with the substitution step here. We're going to take 6y minus 8, 6y minus 8, plus 3y equals 6. So we'll multiply out, we'll distribute the 5. We get 30y minus, what's 5 times 8? That's 40, isn't it? Plus 3y equals 6. Now we can combine like terms. After the distribution step, you're typically going to have to combine like terms. We have two y terms. And 30y plus 3y makes 33y, right? Minus 40 equals 6. Now we need to get rid of that 40. So we're going to add 40. And when we do that, we get 33y equals 46. And when we divide by 33, we get y equals 46 over 33. So a fraction again, a little bit messy. That's our y value. So we're going to take that, plug it into one of these equations, doesn't matter which one, and figure out what x is. And I think, again, this one is probably going to be the easiest one to use because we have this in an x equals format. So let's just plug in y here. 6 times that fraction minus 8 is equal to x. 6 times 46 over 33 minus 8 equals x. So here x comes out to 276 over 33, which is divisible by 3. And when we divide that by 3, we get 92 over 11. So that's our solution for x. So our solution for this set of equations is 92 over 11, comma, 46 over 33. So that point will lie on both lines. And last, we're going to look at the elimination method. Using the elimination method, we can add or subtract the two equations to eliminate one variable. Let's see how that works. So here's a system of equations. We're going to either add or subtract to eliminate one variable. So we can see what we have here is a positive y and a negative y. We can just add both equations together to get a third equation. And what happens when we add a y minus a y? Well, those two y's go away, don't they? And then let's see, we add the x terms, we get 6x equals, and 6 and 12 is 18. And so if we divide this by 6, let's see, we get x equals 3. That works out nice and even. So x equals 3, and then we have to take this x equals 3, we have to plug it back into one of our equations to figure out what y is. So let's see, 2 times 3 plus y equals 6. 2 times 3 is 6, so we're going to subtract 6 from both sides. Y equals 0. So 3, comma, 0 is our solution to the system of equations. So again, what we did here is we found a variable that we can eliminate by adding or subtracting the two equations, and here we add them because we have a positive and a negative y that can cancel each other out. Let's look at another practice problem for elimination method. So here we have an 8x plus 9y equals 19, 8x plus 4y equals 9. So look, we have two 8x terms here, and let's see, if we add them, we would get 16x. We don't want to do that, but we could subtract the second equation from the first equation, right? So let's just subtract everything here. So 8x minus 8x is, well, that goes away entirely, doesn't it? That's the whole point. We want to eliminate one variable, which we just did. 9y minus 4y is going to give us 5y. And 19 minus 9 is going to give us 10. So y here is going to equal, well, let's see, we divide both sides by 5. So we get y equals 2. Y equals 2 is our solution. And then we can take that, plug it back into one of these two, and find out what x is. So let's put it in here. 8x plus 4 times 2 equals 9. Let's see, then we're going to subtract 8 from both sides, right? 4 times 2 is 8. We're going to subtract 8. Minus 8. 8x equals 1. And then we divide both sides by 8. We get x equals 1/8. So our solution here is x equals 1/8 and y equals 2. And that's our solution to the system of equations using the elimination method. So elimination method sometimes can be very easy. Sometimes the substitution method is very easy. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.